All right. Hello, everyone. Welcome here to our presentation. My name is Jules van Kessel. Does everyone's sound work? Hands up if it works. Perfect. So yeah, my name is Jules van Kessel. I'm the CEO of UTF. This is Giulio Tosato, the CTO of UTF. Today we're going to give a presentation about collaborative intelligent multi-agent large language models. We're going to start very simple, explaining like what is an LLM and what are the problems with current LLMs, single agent LLMs. From there on, we're going to go a little bit more into what are multi-agent LLMs. We're finally going to cover the corporate environment, explaining how does this affect the work life, how do we think and what we see as a company, how does that affect the corporate environment, the latest developments, and eventually everyone has the chance to ask questions.
Perfect. So the floor, I guess, is mine. Can everyone hear? Yes? Amazing. Perfect. So here I have two. Maybe we can switch places without falling down. Amazing. Perfect. We made it. So here we have two words, which are really important in the context of LLMs. So we have context and prediction of next token. So I would like to spend some time on the word context, because also for human is really important context. So today I was going around Odoo and I was looking at people speaking, and before doing anything and adding anything to the conversation, I need to understand a bit the context. I need to shut up, listen for 2 or 3 minutes, and after being like, okay, understand what they're saying, then I can contribute in a meaningful way. And context is really important when we are speaking about LLMs. And it's important because thanks to the context, we are predicting the next token. First of all, what's a token? Token is part of a word. You can think as a syllabi. It's not really that neural network define what's a token in order to optimize and to minimize the number of tokens and improve the accuracy. I don't want to get too technical, but the idea here is we have a really nice example. So we are saying, let's say that, let's take the example of ChatGPT. This is the transformer network that is behind ChatGPT. So let's take the example of ChatGPT. We are telling, hey, what's the color of the sky? And it's going to take this what's the color of the sky, and it's going to start generating token after token, word after word. For example, it's going to say, the sky is, let's say that it has already generated these 3 words, and after it's going to say, is what? Is it going to be red? Is it going to be orange? Is it going to be white? Or is it going to be blue? So the idea is that at each word that is going to generate, there are a set of sample, and is deciding for the one with the highest likelihood. So it's everything about prediction, it's everything about mathematics and statistics. So let's say that here we say minus 0.96, which is the highest value blue. So the sky is blue. And just to let you appreciate the amount of computation that's happening behind whenever you are giving a question to ChatGPT, is that for each new token is going to again evaluate everything that you sent and predict the next one. And again, just to let you understand the speed of how these processes are happening. So this is the main idea, but there are problems. Because as we are speaking about predicting the next token, the likelihood, they found out really interesting stuff inside these LLMs. They have a word model that is really similar to ours, but it's still prediction. And we have big problems with prediction because it's not actual reasoning. We can think about hallucination, and hallucination is a structural problem, which means it doesn't mean how better we can make the architecture itself. If we are not changing it, we're going to have it. We can copy in some way, but we are going to have it. And let's say here, did you know that there is no country in Africa that starts with the letter K? Yes, that's correct, apart from Kenya. But it's not correct. And this is an example, a clear example of you are not understanding. Like ChatGPT is not understanding, it's predicting the next token. Sometimes they call it stochastic parrot. So this is one of the problem of single agent LLM. A second problem, and here we took a real case example of Chevrolet, that you have a person that is asking a question to the chatbot of Chevrolet, and is like, hey, what's the advantage of this over this? And I think that a real person would answer in a different way and not praise Tesla. And these are use cases that are already there. There is another use case of Chevrolet in which they ask, can I have a car that is free? And the chatbot was like, of course. And then you also run into legal problems. So these are two of the main problems that we're facing. And one of the possibility, as we said, is not to improve the network itself, but is to multiply the network, give different tools, give different specialities, and modulize each network, and start to have the recurrency that is missing into LLMs. Because LLMs are really good in doing a feed-forward process. It's a bit like when we are drunk, that we are just predicting the next word, we are just thinking, we're not really reasoning, we're just saying, yeah, that sounds good. But what we are doing here is we are modularizing the knowledge. We can see an example from what we are using. So we have an orchestrator that decides basically who is going to speak. And after here for a workflow, that can be a workflow for enterprise software, we are going to have a planner, a writer, a coder, and a critic. And the most important part of this graph is this line. So when I'm speaking about that line, it means that there is a loop. So the process is not going to planner, to writer, to coder, to the critic, and that's it. But let's say that the coder is creating something that is not functional. Then it's going to the critic says, hey, this is not functional, regenerate it. In this way, we can have a lot of loops, and the agent are going to start to fix the error of each other. Now, you could say me, basically, yeah, you have a stochastic parrot, like this LLM, that is not actually reasoning, and then you're putting 5 or 6 of them together. Is there reasoning happening there? Sometimes, and we can say that the reasoning is inside the loop. The agent itself are still stochastic parrot. So, and what we are also believing is that having one person that is not having an LLM that is not really intelligent compared to have 5 LLM that are not really intelligent, and what research show is that 5 LLMs are way better than a single LLM. So even if it's a bit counterintuitive for some people, for some other people it's like, yeah, when I'm reasoning with friends it's always better than reasoning alone. That's what the research shows. So, can go to the next slide. We were speaking about hallucination and jailbreaking. Two quite problems that clients are saying, hey, this is, that AI is there, but how do we implement in our companies in a safe way? So these are 3 possible solutions for mitigating hallucination. One of these is the easiest one. I think you can get without explanation. We have an answer generation and a fact checker. We can use, there are a lot of different parameters that we can play around. Think about the temperature of the LLM, which is the stochasticity. We can play around with the kind of LLM. For example, here we can put one of OpenAI and here one of Google, because they have a different set of training, and that could also help for bias mitigation. Because we know that each set of LLM, each company has their own agenda, and if we want to, an ensemble answer is always less biased than a single one. Then we're going to go in role specialization, which is really interesting. Because here we have not only 2 agents that are speaking, but the agent has actually 2 tools. When we're speaking about tool, and Juul is going to explain better, but it's the agent is actually embodied in the system, is using the system, is not just a standalone ChatGPT, but has access to the system. For example, you can think about here to have an SQL database. So we have an agent that is interacting with the SQL database, and after is sending the SQL queries to another agent that is going to make it human-like. And in this way, you're going to be able to have a human that can interact with an SQL database without having to insert manually the information. Then we have the consensus mechanism. And this is really important because LLMs are stochastic, as I said. And stochasticity, it means that if you're getting an answer 1 minute ago and you're asking the same answer, it's going to be different. So if I say the sky is blue, maybe, or the sky is cloudy, okay? Both are possibilities. So we want to avoid stochasticity. And one way in which we can do it is including redundancy. So when we're including redundancy, what's happening is that LLMs are hallucinating in always different way. But if we can find a baseline, It's a bit what as scientists are saying as denoising. So if all the LLMs are saying a base thing and all of them they're adding some minor things, then the consensus agent is going to add only the thing that is the intersection between the LLMs. In this way, we can fix hallucination. And then we're jailbreak. For jailbreak, which can happen in two different ways. It's not only bad actors, but I was giving an LLM that we created in the company, and I was giving it to my mom, and my mom jailbreak it. She didn't try. She was not a bad actor, but she was actually interested. I was like, no, mom, don't use it in that way. Which is jailbreaking can happen both because people want actually to jailbreak, or people just find use on your tool that you have not predicted, and they can fire back to your company, both on a legal way or just using the client. So what we are using is that we have an agent A, and after we have a guard agent. Here we're speaking about guard agent, but can also be a group of agent. And then we're going into the concept of fractality. So you can have agent of group of agent of group of agent of group of agent. And you can have this structure that are repeating, and these agents are connected in certain way, they have access to certain tool, and that's what we are specialized in finding the best set, the best architecture to solve the task. So that's all from me. Now it's time for my colleague Joe.
Thank you. So I will go a little bit more in depth how this reflects on the corporate environment and also the future of automation in enterprises. So we did a research internally within the company where we checked in the comparative performance of multi-agentic LLMs versus single-agent LLMs in solving complex business tasks. We used three distinct data sets: an employee data set, a financial data set, and a marketing data set, which each data set featured 20 different questions, going from very simplistic questions to very advanced questions like analyzing and other complex tasks. For the research we utilized GPT-4o, GPT 3.5, because they were the most used models. And we used a multi-agent structure of 2, 4, and 6 agents and compared them in terms of quality of answers and the correctness. I want to show you the results of our research. As you can see, the multi-agent large language models outperform the single-agent large language models. And even when you go more in depth of the multi-agent systems, you see that even with more agents, there's a higher accuracy. But what you also see is that time increases. Because there are more interactions between these LLMs, it means that it gives maybe a better accuracy for these specific tasks. For other specific tasks where maybe speed or pricing is more essential, then you can maybe make a better option in having a single agent LLM. I want to give our personal perspective about how we see the future of enterprise and also what we see happening inside the field. This is a very simplified version, but it shows the systems of an enterprise, where the ERP system, how I always say it, is the heart of the organization. The BI system are the brains. And there are many different flows from one system to another. And some of the flows are from unstructured to structured. As for example, when you receive an email and you have to fill in a change in client info, that's an unstructured to a structured task to a CRM. And the structured to structured tasks, these most of the times can already be automated due to RPA implementations. What we see in the future is that there are APA implementations, which stands for agentic process automation. Where these unstructured to structured workflows get finally fixed. Because what we're seeing is that the software, the enterprise software within companies are sometimes even spider webs of structured data, while people are very unstructured. And we see hours a day of a lot of different functions within companies wasted on just typing from one system to another. Maybe some of you have encountered it or know this problem within friends or family. And we think that we see that API implementation, while it's still in the first steps, it can really solve a lot of these issues. So, as I said, agentic process automation, the same way where multi-agents are collaborative, trying to solve a task from input to output, completely automating the whole workflow. So we have some time for questions. Yeah, I'm very happy to answer a lot of questions for you guys. We went very simple, simplistic, and very introductionary in this topic. So I also want to say if there are any people that want to go more in depth with us, our team is here present, also at the Startup Village, and we're also happy to connect or to help people out. So I want to thank everyone for their attention.
Scan the QR code here, then you can write any questions that you might have in the pad. There's one question already, is there an implementation of this for Odoo?
No, there is no implementation for Odoo right now, and we would be eager to discuss. There is, as you can see, this technology, there is a lot of R&D that needs to be done, and that's what we have focused principally. And what we are doing right now is going to market, find the right partner, the best partner, and concentrate our energies there.
I'm going to stand over here because I can't hear you. Okay, the next question is, do you think the use of agents is going to mine the SaaS industry as it is right now?
So, for sure, there are people that are saying that in 2 or 3 years, each company will have their own agent that can create the software from scratch. So you're not gonna anymore go to a software provider, but you can exactly explain what you need. And maybe there will be a new position, a new job position where you can actually be the prompt writer for software. I think that personally this is really unlikely, but in the world that we are right now and with the amount of billions that are in research, I wouldn't say that this is completely out of the background. What I would say is for sure is going to change, and who is going to survive? That's the best question. Who is going to survive are the people that are going to adapt and are going to use this technology, because this technology are empowering the human, are helping the human to concentrate on tasks that are for human and not repetitive tasks that are unstructured, but without AI, a human needs to do it. And the employer will be more satisfied, because it's really difficult to find people right now in 2024 that are willing to do this job good.
Okay, next question is, when I created my multi-agent framework, I use OpenAI's JSON responses as an orchestrator. What are different ways to orchestrate which agent will respond, and how many resources will be allocated?
Can you repeat the question again?
I hope you understand that question, because I do not.
Repeat again.
So when I created my multi-agent framework, I use OpenAI's JSON responses as an orchestrator. What are the different ways to orchestrate which agent will respond?
Okay, so I would say if you want to enter in the multi-agent world, don't start, and you want to just explore it and entry fast, don't start to create the framework by yourself, but there are framework out there. For example, CrewAI, AutoGen, LangChain, something from LangChain, I forgot the name, that are actually doing this. They're doing it in a really, I would say, a naive way. The libraries are still in development, and there is a lot that right now they're adding. But as I say, pay attention, because the space of solution that you can explore and the space of parameter that you can explore is a lot. And sometimes when you don't have right evaluation for this multi-agent system, is even worse than not having them. So focus on the evaluation, focus on finding a framework in order to find the best architecture, and then you should have a result that is acceptable.
Okay, next one is, let me see. Are there currently any prospects for models which avoid stochasticity out of the box without focusing on multi-agent approaches?
We need to change the architecture. We need to change the transformer. Right now, we are in an exploit phase. We are starting now change a bit the architecture, we don't know. For example, with the latest model of OpenAI o1, something is happening. No one knows what's happening, but the performance are increasing a lot. Before, in the past year, we focused on increasing the size because and that was really experimental. We wanted to see how, or actually the big companies, OpenAI and Anthropic and Google wanted to see if we are scaling the number of data and the number of parameter of the model, which is the size of the model, how are the performance going to scale? And they were seeing that we're just increasing till that at the end they hit a plateau, and then they start figuring out new methods. For example, now a method is how can we improve the data? How can we improve the quality of the data that we are giving to the model? Because garbage in, garbage out. And right now another big problem is that we just scraped all the web, all the internet to find data. So now with Project Orion and all these rumors, they're saying we are going to create synthetic data in order to train our model. But I would say that stochasticity is a problem of LLMs. Personally, I have not found any better solution than on multi-agent. I think maybe in the next years, a new architecture will come up and is going to solve the problem of stochasticity. I would also say that stochasticity is not a problem. It can be also a feature. Our brain are stochastic too. But the idea is that we are not just stochastic. We can go in the default mode on just one word after the other, but we can also reason, an internal reason, and do, for example, mathematics, which is something that the LLMs were struggling a lot. So I would say it's not something that we should eliminate, but it's something that should be augmented with other technology. So I still see value in stochasticity.
Okay, so are we going to see, I don't know if you'll be able to answer this, but are we going to see the multi-agent system implemented in Odoo? If so, how would we see the future of integration between the different apps? I don't know how much.
I have too little knowledge about Odoo technologies, so if anyone is interested in a possible partnership, we would love to hear more, but before giving a solution, we need to have multiple talks. Because having something that is bad implemented, I always say to the clients, is even worse than having no implementation.
Yes, I would add to that and say that this year at Odoo Experience, we're having a lot of talks from kind of outside of the Odoo ecosystem to learn more about the future of tech and business in general. But yeah, exactly right. If you'd like to discuss more about how Odoo can be integrated with this tool, then come and have a chat. Right, next question. Do you think that small language models, SLM, with RAG is not better in the future than bit LLMs? Do those words make sense to you?
Then what? Big LLMs.
Than bits.
Yeah,
LLMs.
yeah, probably it's big. Probably it's big. I would say there is not a silver bullet. Even when you go to a company to implement RAG, there are hundreds of different ways on how you can implement RAG. It depends on the data, the amount of data. It depends on are the images or just text? Are there tables? So I would say it really depends. I don't have an answer that is a fit-all thing. So it depends on your application.
It depends. Okay, multiple large language model agents can be used to secure and check each other's generations, but in case of database access with generated SQL queries or using long chain tools with Python script executions, how can the security established with these multiple agents? How can security be established with these multiple agents since they will already be executed?
Since they will be?
Already executed.
Yeah, so security is a big concern, and it's something that we faced recently because we're like, okay, now we have developed everything, but let's say that the agent, because we could even say, hey, this is the password of the database, this is the user of the database, now figure out everything and build the old workflow. And it's something that we are doing in R&D. The big problem is that the agents are going to write code, they're going to install libraries, so we need to create a sandbox environment where we can allow only certain tools that we know, that we trust. And also it's a lot from the part of the client. For example, if we just need read access from the database, don't give us also write access, because then it should not happen, but let's always try to minimize the risk. So try to understand what is the scope of the project. If you just need to read the data and not have access right position.